I goofed up here. I shorted this thing out, and I'll show you how I did that. I had bought this this lamp holder on eBay because it was a lot like the stock one, but because it clips in there just like that. Unfortunately, it shorted out. You see how far it sticks out too far? As you can see, it, you know, it shorted out against ground, and it whoops, it blew the light, and it blew the half of the filament out. One of the filaments, there's kind of like two filaments in here. It's center tapped, and it blew. I don't get any continuity between pin 2 or anything, just 3 and 7. So that tube's it's gone. And also what it did is it burnt out that 330 ohm resistor. It fried it, so I put another one in there. In fact, I had put another one in there, and I turned this radio on, and it fried it. So I'm guessing it's got to be because that the filament blew in here. That's why that 380 keeps on blowing, because it's just that resistor's bearing all the brunt of the voltage now. This is becoming a heater. We'll switch over to the schematic, and we'll kind of investigate on just why that resistor keeps on blowing if that filament's out. But I just wanted to show you the mistake I made by using this lamp holder. Don't get it. It won't work. I'm gonna have to, and that's why I saved this, so that I could modify this. I can't take this cardboard out of here, and I can't get to those wires. I'm gonna take a Dremel and slice it all the way across and try to get this thing off, and maybe try to save this lamp holder, and then find a way to reattach it onto this original clip. The reason I took this off is because the wires were all degraded, and I didn't want it to short out, and I ended up shorting it out. So I learned the hard way. Also, you know, while I'm at it, I'm gonna take this. I want to save this space off, and I want to try using a diode and some resistors to try to make a solid state 35 Z5. So I'll cut off the video here, and we'll switch over to the schematic. Okay, so when I grounded this out, I'm sure I grounded this side right here, and by doing that, that would see the other side was already connected to one side of the 110, and by grounding it out, the other sides, like I said, I've already put that straight to ground, so that this light bulb and this resistor here, let's see if we could put some light bulb in this resistor took 100 and not just that, but also this filament here between 2 and 3, that went to 3 went to ground. So this filament, this resistor, and the light bulb took 110 volts. It couldn't take it, of course, and it blew. And after that, after plugging it in, this resistor just kept on burning up. I'm assuming because this filament was out, and now that's less resistance across everything, and that resistor is just acting like a heater. It's just burning up. It doesn't have the filament and the light bulb across it to help bear the brunt. Now this tube here, it's a 35 volt tube, and if you do the math, let's bring up the calculator here. If you have 35 volts and it draws 150 milliamps, you divide that by 0.15. That gives you 233, roughly 233 ohms. That would be across the entire, both of these filaments. Now I measured between 3 and 7, which is the only filament there. I measured 27 ohms. So if you take 27 ohms away from that, this isn't making any sense. That would mean that there's over 200 ohms between 2 and 3. I don't see how that would make sense. When I get the new tube here, I'll measure the resistance between 2 and 3. But here's just another thing that doesn't make sense to me as far as the Ohm's law, because this light bulb here, it measures, or if you do the math on that, if you have 6.3 volts, which is the bulb voltage, and you divide that by 150 milliamps, which is what that bulb was rated for, you get 42 ohms. And when you put it across the 330 ohm, you get a total of 32 ohms. And we know how to do the math on that. We take 42 and we reciprocate it. Let's see, we'll put that in memory. And then we take 330 ohms and we reciprocate that. And then we add that to the memory. Let's see if we did that right. Okay, so we add that to that equals that, and then we reciprocate it again. Okay, 33 ohms. So that means that there's roughly, when this lamp is in there, there's 33 ohms across this circuit. Well, Actually, I'm not adding the filament resistance, so I'll have to wait on that. But we got to have more than, it's got to be more than that. Otherwise, because if it isn't, then we're not dropping 35 volts here, and we're sending too much voltage to these other filaments. But and then of course I'm not taking into consideration the resistance of the bulb and the filaments when they're heated. When they're heated, you know, it's less resistance than that. You know, considerably, not twice as much, maybe about 20%. I don't know, but we'll when I get that tube in and everything's straightened out, then I'll take some voltage drops across these filaments and do some more math.